Um, Hello, everyone. I'm welcome all on our Data Phoenix webinar. Today, we will speak about generative AI and large language models. With us, Talha uh, Chattha, I
Yes.
hope correct, from AWS. He is AI specialist and architect, and he will talk about today about large language models and how the company can use it and get data from get value from data using generative AI. So I give to him microphone, and
Yeah.
I will uh, start. Um, Not forget. You can ask the questions on Slander. The link is under the video. So at the end of the presentation, we will answer all questions which you ask. So yeah, now Taha, your microphone.
Yeah. Hey, hello everyone, and thank you, Dimitro, for hosting me today, and thank you, Data Phoenix, for arranging this webinar today. And hope to provide some information around large language models or in general foundation models and how they can help with generative AI applications that you or your organization can help to build. Without further ado, I will start sharing my screen, and we could dive into today's session. Great. So, my name is Talha, and I'm a machine learning specialist solutions architect working at AWS. Currently, I'm based in Stockholm, Sweden. I'm originally from Pakistan. Pakistan is in South Asia, for those who don't know. I've been living in Sweden for since 2018 and have been supporting AWS since last year. And right now, my focus with AWS and in general with customers is towards generative AI and how it could help you build applications much faster. Today, we are going to talk about how you could unlock the value residing in your data using this particular technology. A little bit of agenda today. We'll talk a little bit around overview and impact of generative AI, what it looks like in practice, what different architecture patterns are out there, some cost and considerations related to generative AI, what tooling and infrastructure you can get started with, and at the last, we will host some Q&A for all of you to join in and ask amazing questions to all of us. So let's get started with overview and impact. Generative AI right now is one of the fastest growing trends in AI. And it's not just the consumers. In both communities where developers as well as in the consumers are seeing it much rapidly growing. Stable Diffusion, one of the models, a foundation model coming out from Stability AI, which is an open source organization, reached its 40,000 stars on GitHub in just first 90 days. Comparable to Ethereum and Bitcoin, which are also open source and also out there for the last decade or so, it took them years to reach that particular point. ChatGPT, on the other hand, in the consumer world, is a product that came out of OpenAI in late 2022, reached its first million user mark in just 5 days. For your favorite products such as Instagram and Spotify, it took them more than months, like more than 2 months or so, to reach that particular mark. You can already understand that the consumer adoption as well as the developer adoption of this particular technology can unlock many different avenues. Different startups are growing, different businesses are adopting it into their daily lives. And this is happening already. What is generative AI, if we say, since it is booming, but what exactly is it? Nothing more than an AI that can generate content, simply as that. But this particular content is quite close enough to human created content for real world tasks. AI was able to generate outputs for decades or even more than that, but it was not so close to what a human could do or what our brains could do. Now, with this new technology, with new foundation models and large language models, it is now possible. Generative AI is powered by foundation models. These models are pre trained on large sets of data. By large, I mean billions or trillions of data points and billions of parameters out there. I'll explain a little bit later about differences as well. But foundation models in general are not task specific. They're not trained to perform a certain task as compared to traditional ML. Rather, they are agnostic to it and can be customized to multiple domains. And it can be applicable to many use cases. These use cases could be anything such as text summarization, question answering, chatbots, or many other out there. If we talk what exactly do they do, what do these models perform, right? They are doing what we call next token prediction. At one time, they only predict what should come next. For example, in form of the sentence that you see on the screen, the students opened there. That's the sentence that you could input, and the model's task would be to generate the token or generate the probabilities of the token that should come next. For example, in this scenario, the highest probability of the token is books. So that's what it has generated for you. And this particular task could be exponentially expanded to documents which are thousands of characters or thousands or like millions of tokens that could be there, right? Hence, generative AI. To, to exactly do this particular task, how does it happen? How does it work? Researchers and organizations, what they did, they were previously residing only on the data that they had access to, organization data or closed source data. That data was either limited or it was much harder to process and get labels for. Researchers came up with an idea: why not use the entire internet? Why not use the publicly available datasets? Why not use the expansion of data that is already out there, either in form of Reddit, Wikipedia, Quora, or many other sources such as Stack Overflow and others, where there's a vast variety of data already available, use it in a way that could be used for many tasks. So what they did, they collected all of it, whether it be text, images, videos, code, or any other form that they could take hands on, and pre-trained a foundation model. The concept over here, which is quite important, is pre-training. Rather than training a model to perform a certain task, researchers came up with the idea, which I explained a little early, to next token prediction. Inside the corpus, you could self-supervise it. For example, mask certain things in the corpus of text, for example, and ask the model to predict that particular text. You do not really need any particular tokens for or particular labels for that particular that part. You only build an understanding of the corpus of either text or images or any other thing inside that particular model, hence building a foundation. That's why they are called foundation models. Once this model is ready, you could later adapt it to perform other tasks. These tasks could be, let's say, text generation, summarization. You already might have been familiar with chatbots and Q&A systems, and many other out there. What is the difference between foundation models and any other model which you might already be familiar with in machine learning world? A traditional ML model works in this particular manner. You start from a task. These tasks could be the same, such as text generation or Q&A or chatbots. These were already applied in the industry out there. You work backwards from it. You train one specific model to do one particular task. In order to train that particular model, you go on, find the relevant data, process the data in a way that that model accepts, and then outputs that particular task. If you want to perform some other task, you do the process again, go on, fetch the label data, train the model on that label data, perform your task. The first two steps of labeling the data and training a one model for that, this is where foundation models have changed the paradigm. Instead of doing it for each and individual task, researchers found a way to get the unlabeled data, pre-process it in a self-supervised manner, let the foundation model pre-train itself, and adapt it later to the tasks at hand. These could be many other tasks in your organization as well. Key definitions over here. You might have heard all of these names that you see on the screen, but where do they fit in, right? You might be already familiar with AI. AI in general is a very broad field, all the way ranging from simple if-else statements to very complex systems. AI ranges everywhere. Sub part of AI is machine learning. Over here, we have statistical and probabilistic models, which can model the data that you have and find patterns in it. But still, you would have to define certain features, define certain statistics on top of those features, and then perform a certain task. Within that, we have a field of deep learning. Deep learning represents how human brains work in the way of neural networks. These neural networks perform without giving any particular feature. And then, if you expand these deep learning or deep neural networks into big models, then comes what we call LLMs, or more specifically, foundation models. LLMs or large language models sit anywhere between machine learning, deep learning, and generative AI field, whereas foundation models are a subset of generative AI field and LLMs. And that's where we'll be focusing on today. What do these models primarily unlock, and where industry is focusing more on? And what's the core business value that they bring? Search is being optimized using these large models. Generation of content is happening right now with these models. Relevant information is being extracted from huge sets of documents using these models. Summarization is being done using these models. So rewriting in different form of tone, different form of formality is being done using these models. Classification is also one task which these models are being used to perform at a much wider scale. Let's look at in practice how does it work? How do businesses actually work with generative AI or these foundation models? We typically see three form of businesses out there and different roles associated with these type of businesses. Either you could be a provider. What are those providers? Providers are those entities who build foundation models. They take the data either from public sources or closed sources and build these foundation models such that later tuners or consumers can consume them. The skills needed by these people to become a provider is that they need end-to-end machine learning expertise as well as NLP expertise and data science expertise to build those models. And it is quite expensive as well. Then comes the tuner part. These providers, by the way, would be very less people, very less organizations who can afford to do this, who can afford to have their own business strategy and business goals to generate models, right? Whereas tuners could be you, could be me, could be anyone out there who take the models provided by providers and then fine tune them either on their own data or fine tune it for somebody else's data and expose it to the wide world to use, which are consumers at the end. Over here, tuners would still need some ML expertise, but not as much as providers do, and some mechanisms to deploy these models such that others could use it. Finally, come the consumers. These consumers are the ones that are at the end interacting with generative AI, and that's it, either in the form of services or hosting it by themselves and consuming it. No ML expertise are needed, but still application development might still be needed on this particular part, as you might be consuming an API and you would have to integrate that API somewhere. Let's look how provider, tuner, and consumer actively work. What underlying architectures are there for each of them? For example, if you would want to be a producer or even a fine tuner, what would you have to do? You would begin with data gathering. Over here, you process the data towards a self supervised data set, for example, language masking and other mechanisms of it. Or you provide a few examples of the tasks for fine tuning mechanisms. When you gather the data and process the data in a certain way, then you either train or fine tune the model. For training, you would need a huge cluster where many GPUs or many instances are available, and you combine them and you do a distributed training using any of your favorite frameworks and output a model. Once you have a model ready, either through training or fine tuning mechanisms, then you deploy it. For deployment, you would also need to put it on top of an infrastructure. That infrastructure would need multiple GPUs or huge specialized hardware that could be quite expensive for you. You might be chaining multiple models as well. You might not be only needing just one model, you might be chaining a few to output for your particular way of working. And you might also need to think about the principles of filtering the outputs and content moderation and toxicity and ethics over there as well. And finally, you would expose it to the consumer so that uh, they could consume it using prompt engineering mechanisms. When you have it deployed, you would also monitor it. How it is generating. You might put in human in the loop as well. You might try to understand what type of generations are being made, whether they are good or not, And might also monitor the toxicity of these models. Once you know all of this, you might go back and gather either more data, remove some of the data, or filter it or process it in a different way. So this is the process how producers or fine tuners can actually do it. Then, if we deep dive a little bit on fine tuning perspective, previously it was just training, or I touched a little bit on fine tuning. But if we deep dive on it a little, you take a pre-trained foundation models, give it thousands of examples, and fine tune. The actual fine tuning mechanism will update the weights of the neural network running under the hood. This allows a better understanding of the data that you're adapting it towards, right? It is a bit expensive operation. You would need either multiple GPUs or running for a longer time, but still you would have a better understanding at the end of the day for your particular task. Still, once you have a fine-tuned model, the input and output mechanism would still be prompt engineering. But there is another mechanism which we call parameter efficient fine-tuning. Over here, you only need tens of examples, or even maybe 5 or 6 examples. Here, you do not really update the weights. You only add the understanding of those simple examples that you have provided on top of the model rather than updating anything. I call it superficial understanding of those examples. It can still perform really good on the examples that you have provided and many others, but still, in order for you to build deep understanding, you would have to update the weights and go for the first approach of fine tuning. Both approaches are out there, many examples are out there as well to do both of them. It's just a matter of where you fit in, whether you want to spend more money and get better results, less money and still achieve good results. Then comes the question of how consumers would do it. Consumers only need either a foundation model as is, picking up off the shelf, or the fine tuned one done by tuners, provide it handcrafted input, and get the output. Build an application layer on top of it, a front end, a back end, and all of that, and that's it. Nothing more than this. So now you know producers, fine tuners, consumers, and how do they work. Let's take a look at different architecture patterns, how all of this fits in together. First thing over there is prompt engineering. You might already be studying about it, but if you don't, prompt engineering is the mechanism that you provide the input to the model. You tweak the input in such a way that the output matches your particular expectations. Prompt engineering sits in the application layer rather than training or deployment layer. It sits on the interface mechanism, and fine tuning requires either no data at all or some less amount of data. There are multiple mechanisms where fine tuning can come in, and we could have a separate session in explaining what different mechanisms are there. But primarily, we either have zero shot, where you do not provide anything and ask the model to perform a certain task, such as uh, asking the model to generate an email for you, sending out to your manager, right? Or a zero shot would be classify the sentiment of the following review, right, into positive, negative, or neutral. This could be an example of zero shot. One shot would be that you provide one example of it, that okay, this is a sentiment and the review of this, this is a sentence and the review sentiment of this sentence is positive. Classify the next sentence for me, and the model tries to classify it for you. Whereas few shot is that you give maybe 3 or 4 examples of the similar task that you want to perform, whether it be generation, summarization, classification, or anything else, and you let the model follow the similar pattern for you and output the next thing. And there are other sophisticated approaches of doing this as well, which we can follow up later. But this is the interface how you communicate with any of the foundation models, and model provides you with an output. Elements of a prompt include, or a good elements of the prompt are that you have an instruction, what you want the model to do, a context which is relevant to your input, the actual input that you give, and an indicator that after this provide me with an output. In an example on the screen, the instruction is summarize the following restaurant review, right? You are letting the model, you are asking the model to perform the summarization task over here. You provide a context, which is the name of the restaurant, location of the restaurant, and what the specialty of the restaurant is. Itself, the review, what the review was provided by the customer, for example. And you ask the model, you provide an indicator that after summary and colon give me the summary of the entire review which has been provided earlier, and the model will do it for you. So this is how prompt engineering works, and you could sophisticate it depending on your particular business. Now, once you know how prompt engineering works and how can it solve your business value, then comes the part, what do you want to do? And what if a question comes over here, what if I have large documents, right? What if my document does not fit into the input window of the model? What do I do then? Then you take that particular document and you convert it into a numerical representation, which I call embeddings model. So previously you had a foundation model, which is responsible for generating an output in form of either text or images. But over here, you have an embeddings model, which converts your text into a numerical representation. I will dive into later why this numerical representation is needed. But let's look into certain patterns. And these documents, when would you need to generate numerical representation of these documents is when your documents grow, let's say around 10,000 words or 10,000 tokens. Some examples of those could be, let's say, call transcripts or product manuals, some books, code bases, or any other similar sort of data that you have. You would want to have numerical representation of that. Let's look at the first pattern, which is text generation with context. What you would rather do, you would provide a context as I previously did. You would provide a task and let the model understand both of them, the context and the task, and the model will generate an output for you. An example of that would be, let's say you ask the model, your task is to write a polite email based on the context below to the customer, right? You provide the context. Who is the customer? Customer is John Doe. Who's the manager? Bob. At which company does he work? Any org. What is the input, right? Customer provided negative feedback on the service provided by our customer support engineer. So we have to write an email back to that particular customer. On the right hand side, you can see the output that the model did. This is an example of a zero-shot task. I did not provide previously any example over here. I just provided a context and asked the model to generate something for me. Most of the foundation models and large language models can perform these zero-shot tasks really well if you form your input in a good way, or if you form your prompt in a good way. Okay? And hence you could do text generation like this. Over here, you do not really need any representation, numerical representation, since you're not inputting any particular document of your own business. But what if you want to do that? Let's look at the simple pattern first. Let's say you want to ask certain questions, contextual question answering. For example, you have a very small document, which could be, for example, a resume, and you would want to know whether the person has a certain experience or not, whether a person is experienced in Python or not. The model will be able to understand the resume, find the answer whether he or she is experienced in Python, and provide you with an answer on it. What if that resume grows, or what if there are more resumes and you want to find the answer to, like, how many candidates are there with Python experience? Give me a number, and there are like 10,000 resumes. What do you do then? Right? Then comes the second approach, what we refer to as retrieval augmented generation, or in this case, retrieval augmented question answering. Over here comes the question that you take that data that you have, resumes or any other sorts of data, create a document store. This could be your frequently asked question, your wiki, your internal documents, or product manuals, or many other things that are there. Use an embeddings model to generate the numerical representation. Save that numerical representation in a vector database for later uses. Once you have that knowledge base created, you'll expose it to the users. Now a user asks a question. You go on, fetch the documents relevant to that particular question, add it inside your context, give it to the model, and model generates an answer. Why this is needed? Because you cannot fit in all of the things, with all of the resumes, facts, or whatever documents that you have inside a model. Since you cannot do that, you would only want to fit in the relevant information, right? Once the relevant information fits in, then the model is able to find the relevant answer for you as well. How to store in a vector DB, what vector DB to use, what is this knowledge base, what embeddings model to use, what foundation model to use are the details which could be solved later. But in general, if you want to solve, if you have large documents which need storage and which you need to ask questions on top of that, this is how you do it. Let's take a look at how chatbots could be built by yourself. You might already be familiar with, let's say, ChatGPT. Maybe that's the reason why you are here and you are curious in knowing how you could do something similar to that. This is how you do it. A very simple picture of that you have a user asking a certain question. Either that user has a previous chat history, which could act as a context and you could feed into the model along with the new question, and the model gives an output either based on its own learning or tries to fetch it from somewhere else, right? And this loop goes on and on and on. But what if the model doesn't have that information by itself? What if it has to fetch it from certain document or another tool out there? What does it do? What does it do then? Then we dive a little bit into the detail of it. Over here, a user asks a question. What happens then? That the question goes to the model. Model, you fetch the chat history. You also fetch the documents. Some embeddings are generated for those. Either it is stored in memory or in one of your vector databases. And then that goes on back to the model. That foundation model and your chat history is fed into it, and then you get an answer back on top of it, right? And hence it goes on and on for all of your chat-based experiences that you have inside your organization. And this is how you build these applications as well for yourself. So two components. One is a foundation model of your choice, whatever you choose, and another embeddings model needed to embed or to create numerical representation of your documents. Once you have all of this in place, you know what you want to do, what architecture pattern you want to follow, and what is the application that you're trying to build. Comes the question of choice. What foundation model to use and how to use it, basically. We see typically three patterns out there. One, use the models as a service. For example, OpenAI is providing a service, which is ChatGPT. Google is providing Bard. Microsoft is providing through Bing and other mechanisms. AWS is also providing it using Amazon Bedrock, right? And other options available as well. There's also options of using proprietary models from third-party providers. Over here, names could be Cohere, Lighton, AI21 Labs, Anthropic, and Midjourney, and many others which are out there. Then comes the third option, which is one of the fastest growing options, is the open source community. Over here, you have the option to use Stability AI to use image-based models, Alexa teacher model from Amazon, which is also open source for text-based mechanisms, and a wide variety of models available under Hugging Face Model Foundation Model Hub. Once you choose what model to use, comes certain cost perspectives. How do you evaluate them? The first thing that you would have to consider under cost is the decision of approach. Whether you build by yourself based on all the teachings we had earlier, whether you train or fine tune or do all of that mechanisms, you build it, or you buy it. And there's a spectrum in between as well. On the screen, you can see what benefits you get from each of those approaches. So let's say you want to build a model by yourself. You either want to train it or fine tune it. You get the full customization potential. You have the capability. You can tune it however you want. You can bake in all the capabilities that you want. But at the same time, it would be quite expensive. You have to pay in a lot. But since you have to pay in a lot, you also have the control of the cost structure as well. How do you control those costs? You would need a lot of skills to build it by yourself, and you also have the control of how to protect data, how data privacy and residency can be ensured. And obviously, you have the intellectual ownership of it. Then comes the option of whether you want to self-host it or use the model as a service. What capabilities are there? It is quite cheap, relatively cheaper, obviously, than building by yourself. But at the same time, you might not have the capability to own the intellectual property of it, since it is a service owned by someone else. Data privacy, you are also residing on someone else to either provide you with regulation that yes, we are complying with some certain compliance mechanisms, or you take their word, right? Also, cost structure, you cannot really control it. How they are running their business, you cannot control it. So you have to evaluate your entire business model in this paradigm, whether you build something or buy or mix them both. Once you know what you want to do, you also need to understand what each and every component costs. Let's say you make a decision of training a model. I'm not going to give any particular dollar numbers exactly, but I just want to compare all the options over here. In training, you would need the data itself, gathering the data, processing the data, and the cost of having the data, all of those. You have to bear those costs. You have to bear the costs of the infrastructure and to distribute that infrastructure, to have distributed training and keep it running for several months for good output to be generated. Then the second, fine tuning. Fine tuning is relatively quite cheap as of today with GPUs available, and these models tend to perform really good with very simple fine tuning as well. Whether it be parameter efficient or even updating the weights, you could do it in a couple of hours or even minutes if you want, and with very few examples. It's quite cheap. But at the end, deployment. These models are quite big, so they require you to deploy them on either specialized hardware or multiple GPUs out there. So it's relatively expensive than fine tuning. So keep in mind when you try to make a decision of what you want to do. In fine tuning, you only need some data examples and some infrastructure. You do not really need to distribute it. But in deployment, you need access to some infrastructure and you need to have a scalable mechanisms so that you could scale out to all of your customers out there. So a little bit around costs. Now comes the question considerations. Since these models are quite good, large language models are amazing, you can do a lot of things with them. But what are the limitations? What do I have to consider before making a decision? I try to put generative models or large language models or in general the field of generative AI in the spectrum of deterministic and explainable side versus non-deterministic and non-explainable world. On the deterministic side and explainable side, you would rather put algorithms. For example, you need a forecast generated for the next month. There are statistical models which can efficiently do it, and you can explain how that particular forecast was generated, which would be very relevant for financial services and other businesses out there who need explanation. On the far right sits generative AI, where you are subjectively generating something. Let's say whether it be emails, whether it be summaries, whether it be chatbots, or something else that you are generating and letting the machine do the work for you. You cannot really explain how this particular output was generated, neither can you be deterministic that this is the output which will be coming out. Somewhere in the middle sits the whole world of machine learning. Some of the things over there are deterministic and explainable, some are not. So you would have to be considerate about what exactly do you want to do. Some risks and limitations associated with generative AI is that there is a systematic bias based on dataset in many of the foundation models out there. Why is that the case? Since these models are trained on huge amounts of data and that data goes to trillions of examples, it's almost impossible to root out the bias. Let's say if we talk about bias of language, most of the models that you see out there are trained widely on English language and support of other minor languages. So, for example, I'm in Sweden and people over here speak Swedish, and my neighboring countries are Finland and Norway, and the languages that they speak are Norwegian and Finnish. And the data available for all of these languages is quite scarce, either due to population or many other reasons. Since the data available is very less, so what could go into training of a model would also be quite less. And some other languages might be bigger than what is available. So a systematic bias automatically gets introduced. So it's a risk out there. Another risk, which is actuality of knowledge embedded in the models. What that means is that since you train a model, let's say you decide to train a model today and you end up training it up until tomorrow, so all of the information available until tomorrow is the only information that is stored inside the model. anything happens which happens next week or next month, the model will not have an understanding of it. It might have an understanding, but it will not know exactly what happened, right? Let's say a president of United States or president of Sweden gets changed in a month. The model will not know. If you ask who is the president of United States, it will still say Joe Biden, since but it has changed in the next month, but model doesn't know. Also, a risk is hallucination. As the word itself says, generative AI, it is responsible for generating something. There's also a risk that it would just generate something which is not real, right? It is responsibility of you as a human to decide whatever it is generating, whether it is real or not, or it is just fake. Content moderation as well, that since it is generating something, there is a possibility that it generates something NSFW, not suitable for work or not suitable for adults or kids or out there, that you would have to moderate that what is coming out of it. Similarly, some limitations. If you're talking about it, that it might generate something which is not specific to your domain. It might not understand a certain context. We as humans are great at understanding sarcasm. Models might not. They're huge models. They're cost intensive. Model inferencing is there. And yes, explainability is not into these models at all. As of today, researchers do not have a mechanism to explain how a certain generation was done. Some recommendations, some strategic recommendations on generative AI. Keep your eyes wide open. This is a very new field. Things will change. More and more options will come out there. Do not stick yourself into just one thing. No one size fits all. It's not just one model that can do each and everything that you could imagine of. There are some specialized models. So, for example, for summary, for chatbots, and for other mechanisms, try to explore them depending on your use case. It's the first time in history that the open source community is moving much, much faster than any big giant or any organization out there. Right? Keep an eye on those open infrastructure platforms and try to learn from them as well and try to evaluate the options available and listen and enable. Try to understand what is it that your customers are trying to do, what is their problems, and try to solve those problems first rather than being just curious. So now you know different components, how generative AI works, what different mechanisms are there, what were the patterns, what is the cost associated with each of those. Let's look a little bit into tooling and infrastructure. What is it that you would need? You would need a model, you would need a deployment mechanism, you would need some storage where you would put your documents, some integration mechanisms to connect them all together, and finally to visualize an application. To get started, or the lowest hanging fruit would be that you get the model from Hugging Face, which is one of the widest open source community of models. You deploy the models on a service similar to Amazon SageMaker or any other of your choice, which can already provide you with infrastructure and deployment mechanisms in a much easier and secure way. You could store your documents in the numerical representation in, let's say, Amazon OpenSearch or other vector databases available out there. You can integrate them together using an open source framework called LangChain, and very easy to build applications on top of Streamlit. This way, you can already get started with building your applications in a much, much faster way. You can build, for example, a chatbot in under a day using any of these tools. With the first three segments, AWS can help you readily. So, for example, we as AWS already have integrations with, let's say, Hugging Face. SageMaker is a platform which is already available to you. There are certain free tiers in SageMaker which you can leverage and deploy your applications. And also OpenSearch, which can help you store your embeddings of the documents. And hence, you can build your applications on top of it. There are also mechanisms to use other tools such as Streamlit and LangChain on top of AWS using, let's say, EC2 instances or Lambda functions for that part, but we will not dive into it today. Well, this being said, this is the most easiest way to get started or build your own application. There are also certain services available in AWS stack for you. So in the entire AIML stack, which is a wide stack with over many services, we have introduced services or features or tools for different segments. So for example, if you decide to become a provider, We have specialized hardware available for you to build these models or train these models and deploy these models at a much cheaper cost to you. So, for example, AWS Trainium is a specialized hardware just for training deep learning and big, large models, and many customers are adopting it. Also, AWS Inferentia, which takes keeps it much cheaper for you to deploy these models and much faster to have the latency and like lower latency and faster outputs. For tuners, SageMaker Jumpstart is an amazing world where you can pick up many of the models available already and fine tune them either on your data or use them as is if you want to. And finally, for consumers, services are out there. So we have announced Amazon Bedrock, which is one of the easiest way to get started with the generative AI. Basically, foundation models as a service are available over there. We are already building our own foundation models by the name Amazon Titan. And some of the services are available in the code and DevOps side. For example, Amazon Code Whisperer, which can augment with developers' experience already today to get started. To give a little bit of a summary, some of the new offerings which I just mentioned: Amazon Bedrock, Amazon Code Whisperer, and Amazon EC2 instances. Over here, Bedrock, as I mentioned, is one of the easiest way to build and scale generative AI applications with foundation models, and Amazon Titan as our own first-party model is available over there. Code Whisperer, which you can leverage to build applications much faster, is available and it is free to use for any individual developer. If you want to use it in an enterprise context, we can talk to you and we can arrange how to use it for yourself and what could the pricing look like. But for you as individuals, if you want to develop, go on, use it. It is for free as is. And if you want to become a provider, you can talk to us. We, as specialists and solutions architects, can work with you in order to architect your models on top of specialized hardware provided by Amazon. So that's pretty much it from my side. Please scan this QR code. Please provide the feedback for this session, and we'll open up the floor for Q&A.
Yeah, thank you for amazing and very interesting presentation. Um, yeah, please ask the question on Slander. You also can scan this QR code and go to the Slander and ask. Also, the link is under the video. And participate in the survey. The feedbacks is very neat for us. Yeah, so we have the
Also,
first.
the survey QR code is right on top of the screen as well.
Yeah,
So just
yeah,
above Slido, uh, you could ask those. You could scan the QR from there and provide the survey. It would be really helpful for me to keep on doing this so that we could have later sessions as well. So the first question: if we use a foundation model as a service and fine tune it, what happens to the data with we train? Who can access it? So Satyaki Chatterjee asked this particular question. It is dependent on each and every service who is providing the service and what are their data privacy regulations and laws and under what regulations are they covered. It might be the case that, so for example, with Amazon Bedrock, which is AWS service, they don't store your data. Nobody has access to your data. Your data comes in an encrypted format. Nobody gets to read it. Nobody gets to see it. The model is trained, fine-tuned for you, and then made available to you in an encrypted manner only, such that you have access to your data and your model inside the service just for yourself, right? And nobody can access it. I cannot really comment on what other services do. So, for example, OpenAI with your ChatGPT and other vendors available out there can do multiple things. So, their features and their regulations you would have to study by yourself.
yeah. Please continue ask the question. I have one question about. Um, do you think LLMs it's good way, good option to use for some recommendation system? For example, to not use the standard filters in the website, but use the chat, which then will recommend something from the catalog of the website.
Absolutely. So a lot of our customers and we are working with them in order to build such systems. A famous flight booking website where you could book flights is already integrating such kind of a mechanism into their service, where they allow the customers to communicate in a chat format to find the flights as well as book them using these LLMs, powered by basically LLMs and application on top of it. And some other websites similar to that for retail purposes and hotel bookings are using something similar. And we as Amazon, like a Amazon parent retail company, is already putting foundation models in many of their services. So it is a great use of those. And together with application integration and tooling available, they can do wonders already. And I would highly recommend and would like to work with any of you who would like to build such kind of applications. Are
Yeah,
there any options for multi?
I
Sorry, you
yeah.
have a follow up. Sorry, go on.
Yeah, a little follow-up. Yeah, it will be interesting to discuss with you some this case how to better to build some architecture of the application of the system of using LLM for recommendation system. Yeah.
Yeah,
Okay.
um, so for example, in terms of recommendations, these models, since large language models works on the principle of prompt engineering, and you could shape up the prompt however you want. There are sophisticated manners of shaping up the prompt and connecting these models to any of the tools available. So, for example, you have the context of the user, who the user is, what the user is doing, what kind of personality or the user profile do they have, what products do I have. Get the information of the products, get the information of the user, and let the model understand both of them and provide that among the list of these products that I have, based on this user, what would suit them best. The model can output you that this is the product based on the information that you have provided. This is the product that makes most sense based on this reason. And then you take that output and suggest that to your particular customer, whosoever he or she is. Right.
Yeah.
Okay. Are there any options for multimodal models? Yes, there are quite many options out there. But then at the end of the day, it depends on exactly what your use cases are. So I would not vouch on one model because these models, to train them, it's quite hard, and there's not enough data available out there for these kind of models. So the performance is really poor. I would rather go for other approaches to combine multiple systems together, such as an image based model and a text based model, and combine the outputs of the two to perform the task at the hand rather than using one multimodal model. What could be the probable mechanism to reduce hallucinations from a fine-tuned model? Uh, well, from a fine-tuned, so at first let's talk about the original foundation model. Most of the foundation models, if you prompt them correctly, so for example, inside the prompt and inside the instruction, you ask the model, do not provide an output if you are not sure about it, or do not try to come up with answer, only answer based on the context, then most of the models try to stick to it. So, for example, I have experienced it with Anthropic Claude model. Anthropic is a company which have built a model by the name Claude. If you ask that particular model, do not try to come up with an answer, it will not. It will try to stick to the context that you have provided. If the context that you have provided does not have an answer, it will try and it will just say, I do not know, or the context doesn't have the information, or anything else, right? But now comes the question of fine tuning itself. In the fine tuning, since you provide the instructions and the prompt and the outputs, inside those instructions and those prompts, you would have to introduce a mechanism of not hallucinating, basically. You would have to tell what should the model do if the relevant information is not available inside the given input. And if you do that, then you can remove hallucination to a certain extent. But 100% removal is still not guaranteed by anyone as of today. More research will be needed. So, Anatoly, is the development of LLM or AI in general following the path of smart devices? Are they everywhere and always with us? Well, this is quite interesting to see. Any adoption takes time. Today, LLMs are pretty big. They are like huge. So, like, you cannot really deploy a huge model on your phone, for example. It will eat up all of the memory available in your phone. Or you cannot deploy them on IoT devices in a car or in a microwave or these kind of things. So you cannot do that today because of their sheer size. Since that cannot happen today, so it's not really possible to be everywhere and always with us as of today. Later down the lane, maybe these models would shrink and the capability would grow, and maybe we would see more of adoption happening at different places, and devices and applications becoming more smarter with this technology for good, hopefully for good, and people would follow the ethical principles to make them good. But I would not see that happening personally. I would rather see them being in cloud, being in the specialized hardware, unlocking the value of the enterprises in a much more larger scale rather than being on smaller devices, unlocking smaller value. For that, many of the machine learning models already exist, which perform tremendously for those specific tasks. So, not really LLMs on smart devices or IoT devices per se. I hope that answers.
Um, yeah, I think it was the last question, but if you have more,
Mhm.
please write.
And please, if you have already not provided the and if you have not completed the survey, please try to scan it. It would just take you under 30 seconds to complete it, and it would help me a lot.
Um, I think I will also send the survey after the webinar with a recording to the people, so they maybe after also participate and give some feedbacks for us. So yeah, uh, uh, I want to say thank you for your presentation, for your sharing your knowledges and very interesting introduction to LM and fundamental models. Uh,
Yeah. Thank you so much for hosting me and giving this opportunity. And I hope to have more of these sessions so that we could provide and uh, give the knowledge back to the community and whosoever wants to learn about it.
yeah. Yeah, and thank you for all who was with us. Don't forget to subscribe to our YouTube channel to know about our next webinars and get access to the all recording previous webinars. So thank you all and see you next week.